Hello everyone, I'm Lara from Eprosima, and today I will host this embedded working group. As a recap, at the last meeting, Dr. Leah Ovsyannikov, co-founder of Remake AI, discussed the integration of micro-ROS into open source home pet companion robots developed at Remake AI. The talk covered the architecture of these robots, the utilization of micro-ROS, and the wide-ranging benefits it offers to consumer robotic products, including improvements in architecture and economics. And today, Dr. Jon Durrant, founder of EA Ltd, will discuss the complexity of maximizing Raspberry Pi and Pico capabilities for robot architecture. So, Dr. Jon, it's your turn.
Thank you very much, and thank you very much for inviting me in to be here. So, is my screen sharing okay? Can everyone see it? Brilliant. That's good to know. So yes, I want to have a slightly whimsical look at my own experience of micro-ROS and building some robots, primarily with Raspberry Pi and Raspberry Pi Pico architectures, and bringing that together and talking about actually how we create a maximum Raspberry robot architecture. So what do I really mean by all of that? He says as soon as he gets his screen to work. There we go. Well, when I first got into robotics some years ago, like everyone getting into this in the beginning, I tried to build everything on a single platform. So I needed more capability. I ran up an additional node in ROS and put an additional capability on my single board sitting on the back of my hexapod at that point. And I primarily work with Raspberry Pis, so it was a Raspberry Pi 4 powering that. Now the problem with that approach is that you can't vertically scale Raspberry Pis very far. Fortunately, now we've actually got a Raspberry Pi 5, so actually as soon as Jazzy comes out next month, I might be able to scale a little bit more on that. But just waiting every 4 years for Raspberry Pi Foundation to release a new Raspberry Pi is not a very great solution for vertical scaling. So vertically scaling in my Raspberry Pi ecosystem for robotics just doesn't really work very well. So that forced me very much to start looking at, well, how do I horizontally scale? And can I horizontally scale? Now, of course, I can horizontally scale, and I love doing that because distributed systems is actually where I got into the world of IT. It's what I did my PhD in some too many years ago to remember. So I want a horizontally, and I've been playing with these horizontally scaled robots and placing all of that capability in there. Of course, we don't want all of those nodes to talk together in custom interfaces and protocols. That would be just a complete mess. So like every good IT person, I want to organize them so that we have a common bus and that we're talking in a common protocol and probably doing publish and subscribe. You know where I'm going on this because you know what architecture I'm going to talk about. And you know that actually those raspberries are actually Raspberry Pi Picos that are doing some of my low-level controls and low-level programming, and Raspberry Pis, which are actually doing some of my higher-level functions and thinking in my world. Of course, the backbone to that is ROS2, and every one of those Picos is talking and using micro-ROS. I, of course, being me, have added FreeRTOS Kernel into there. I use that as the real-time operating system to give me multitasking. I'll explain a little bit more about why my choice of that and how that works a little bit later in the talk. And I even add in the odd VM cloud service sitting in the back there talking into the world as well. So that's really the architecture I'm going to talk about. So what, hopefully with a little bit of a hook, so you're all now awake and thinking, well, what's he going to say? What I'm going to talk about today is going to be, first of all, a little bit of an intro to me and who I am and how I got into this mess in the first place, about my Pico robots that I've built, about this robot architecture and how I'm using micro-ROS in this Raspberry Pi ecosystem, and finally some of the challenges that I've had, some of which I've solved, some of which I still need to solve. So I'll tell you a little bit about those and my experience in trying to get up to speed with micro-ROS. So to introduce myself, my name's Jon Durrant, and really I'm probably an alien here because I'm not really a robot engineer. Well, I sort of am, but it's not certainly where I started my career. I'm really an IT architect, an enterprise architect, and an IT leader. I've worked in lots of companies, from food retail to financial services, travel and tourism, and entertainment, trying to help those organizations align their business strategy and their IT teams so that actually their organizations go in the right direction. And that's really where I come from. The robot side and the embedded system side is my hobby and has been a hobby for a while. Building distributed systems, building lightsaber IoT devices, and playing around with hexapods and other robots. I had the great opportunity back in 2022 to make my hobby my job. So I now spend my time training people to be able to write embedded systems and IoT systems, etc., on the Raspberry Pi Pico platform on Udemy. I also do some higher level courses on Udemy on things like IT strategy and data strategy as well. And that all led me into the world of YouTube and becoming a YouTube creator as well, because as soon as you build your own business and you start training people and you need to encourage people to your product. So I had to become a YouTube creator to do that. And I do a little bit of consulting as well, because that helps to pay the bills. So that's a rather different world that I come from and what I do. So I started my journey into robotics actually with ROS 1 some years ago, but certainly before the Pico existed, and I think before micro-ROS existed. Certainly I don't remember seeing micro-ROS at that point. And my hexapod there is a kit by High Wonder, of which I dropped the entire software stack and wrote it all in ROS 1. It's all running on a Raspberry Pi, but it had the problem of being a very large Raspberry. It was a single node and scaling was a problem. Everything had to fit on that one single board computer. So when I came back to this world fairly recently and looked at it from the ROS 2 and the micro-ROS world, I loved this opportunity because suddenly distribution became a really easy opportunity for my robots, and to build with micro-ROS and multiple micro-ROS instances, using some FreeRTOS as well to maximize the capability of my Picos. So my first journey into this was a very, very simple robot, what I consider to be a very simple robot. It's a video turntable because I needed to get some video shots of things rotating. It is a robot, it moves, it has a joint. It has just one joint, admittedly, but it has a joint. And that joint is controlled by a stepper motor with a Hall sensor detecting 0 position and controlled from a Pico. And then we have ROS sitting in the background doing some of the higher level functions capability of working, thinking about speeds and angles, etc. Of course, I can even model this sort of robot in URDF. It's not too challenging, but you know, it is a proper robot. It does have joints. It does publish its joint state even. And from there, I decided to jump into the world of a three-wheeled robot and a little buggy that walks around. So this is DDD, my DIY dev droid. Its motors are all controlled by a Raspberry Pi Pico. Its high-level brain is a Raspberry Pi, which is handling the odometry, mapping, and communication. Planning and navigation are still a work in progress, I will admit. But yeah, it very much is a DIY and development droid. You will see that the electronics are not even on the PCB, they are on a breadboard sitting on its back. But it demonstrates the capabilities very, very nicely. And even for Christmas, I decided to create a little bit of a fun robot, a robot Santa. He again is a Raspberry Pi Pico controlling the servos and the eyes and their colors, and then a Raspberry Pi which is doing the video processing, so it is doing face tracking and face detection. It actually recognizes me and turns the eyes blue to show that I am the blue-eyed golden boy that obviously is very good and getting lots of gifts next Christmas. So all of these robots have the same basic underlying architecture. The high-level functions like face detection and face tracking, etc., are all done on a Raspberry Pi. And the low-level functions to control the motors and work with any sensors or servos, that's done via a Raspberry Pi Pico. And really, I'm, I guess, going to now delve into a little bit more into what's in the architecture and running on that Pico and how am I using micro-ROS, because this is the embedded working group. So I think that's probably the more interesting side of this. So I've already admitted that I'm using both FreeRTOS Kernel and micro-ROS and using those together. Micro-ROS, I'm therefore delegating a little bit to just being communications. And then my FreeRTOS kernel is providing me all of the tasks, multi-processing and communication between those tasks running on the Pico. Why do I choose to do that? Well, micro-ROS is a RTOS of a sort, I guess. But my experience, I suppose, is a lot more in FreeRTOS. And also, I want to be able to break up my projects into smaller components that I can check that they work and run them with a test framework. And I found that a little bit easier to do using FreeRTOS, and I have lots of FreeRTOS builds that allow me to do that. So I can componentize things, check that they all work, make sure that I've got, you know, motor controls work, I've got speed control and PID models that are working, and then I can combine them together within the framework to actually deliver the robot itself. So the architecture I run all therefore sits within FreeRTOS as a framework, or FreeRTOS Kernel as a framework, and the scheduler. And I'm able to then run that either single core or dual core on the Raspberry Pi Picos. That's really easy to do. And then I can use micro-ROS that becomes a bridge task, a single task, because that gets me around having to worry too much about concurrency controls within the micro-ROS code itself. If I just run it in that single task, and then I can have other things talk to that task through request to take messages out and be notified of events happening or messages arriving on the Pico, or publish information out. So things like my motors and my sensors, they all become other additional tasks that then are communicating using FreeRTOS primitives. Communication is, of course, really, really key in this distributed world. And the Raspberry Pi Pico has an incredibly odd architecture for, I think, at the C and C++ level, in that you can actually have 3 standard I/O stacks, all working there and choosing which message goes to where. So I'm actually using 2 at a time. So I have USB, which is providing the micro-ROS communication and is absolutely all standard I/O, much as it is in the standard demo micro-ROS instance. And then I've got telemetry, also standard I/O coming out. Telemetry is really important to me because I need to know what is going on that Pico when I'm developing. So I do need all those little printf statements telling me what's going on. Otherwise, I wouldn't get very far with my development. My code wouldn't do anything. So it's really key that, of course, that USB communication going off to the world of micro-ROS is resilient and performant. And we'll come back to that because I've had a few challenges with that on the Pico. The telemetry then becomes the visibility and a debugging channel for me to actually understand what's going on. So what is in that micro-ROS bridge task? Well, I of course have the ability to publish messages out onto the world of ROS2. I can also subscribe, and I've got message handling running through there. So it is, in fact, acting almost as a broker, taking those messages in and then sending them out where necessary within my FreeRTOS kernel world. What I haven't got in there right now is actions or services. I haven't felt the need yet, but those are definitely missing bits. The bit I have felt the need for is RCL CPP, so the C++ binding, which would have been nice because that's got the PID algorithm in it, and I sort of missed that. So we'll come on to that now as we talk in a little bit about some of the challenges and some of the things I've found working with the world of micro-ROS. And really, those challenges fall into 3 categories. A bit around resilient comms, a bit around custom messages, and having the C++ binding. So resilient comms. My first experience playing around with micro-ROS, I found quite frustrating because I got lots and lots of communication dropouts going. Partially, I think, because of the way the Pico uses USB, but yeah, that took a little bit of work to work out what was going on there and try and make that as resilient as possible. So I've now got quite a detailed state machine in my model to try and maintain and keep comms up and regenerate comms if it should drop. That may be being made worse because of my communication stack and the fact that actually I'm using standard I/O in 2 directions, both for ROS and for telemetry. And on my most recent robot, which is a robot arm, actually I've got bus servos, which I'm also communicating to over UARTs. So there's a lot of serial communication going on this poor little thing. There's some other bits of comms that I really want to try out and haven't. I haven't yet got around to trying out micro-ROS across TCP or UDP. And I am intrigued at the opportunity for maximizing my Raspberry Pi Picos in my robots, and therefore having something like RS485 as the backbone and having a number of Picos talking on that same bus. But those are experiments I really haven't done and want to do. The world of custom messages I found to be quite a frustrating thing to try and do with micro-ROS. I forget to that I've got to copy the changes I make to my standard package for messages over into the MTU workspace to build, and therefore do lots of builds that are useless, to the extent that I actually wrote a little script to actually manage to copy stuff over as part of the build, just so that I didn't have to remember to do it myself. But every time I change a custom message or introduce a custom message, rebuilding my libraries is quite a time-consuming business in my environment, and something that really puts me off. And is, to be honest, is forcing me to misuse standard messages quite a bit, because I'd rather find a standard message and misuse its intent than try and write a new custom one because of the compilation pain. But what I need to do and find some time to do is to actually work out how can I actually build that custom message so it becomes its own unique library for the Pico for linking purposes, so that I decouple that from the standard micro-ROS library. I'm sure that should be possible. I just haven't worked out how to do that yet. As I said around DDD, when building DDD, I actually had to write my own PID implementation, which is fine. That was a good exercise to do. Though one gets worried that, you make little mistakes in that, I'd rather use a standard library for it if I could. But I haven't actually got the CP++ binding currently compiling into the Pico. I see and read online that it should be possible, but there are a few challenges I know to get over. But again, it's something else that can be done, but it's quite time-consuming build process when it goes wrong. If only I could build on my Mac properly. I really need to find time to work out how to do that too, rather than my Raspberry Pi 4, which is often my build environment for ROS 2. So, in conclusion, I've found this whole micro-ROS thing to be brilliant. It's helped me go from the simplest robots with single joints up to mobile robots, driving them around my house like remote control cars, and even now helping me working on a robot arm, 6 degrees of freedom robot arm. So all underpinned by this architecture of actually using micro-ROS to do the low-level control and placing all of the high-level control on a Raspberry Pi. And I will say that micro-ROS has been a huge accelerator in this. If I was trying to do this from scratch without micro-ROS there as a package, this would be immensely more difficult. So, that's really, really helps. And then adding into that FreeRTOS, so that I have all of the capabilities of the full-fledged real-time operating system, gives me really powerful architecture to provide those local services and even link out to some other cloud services on the side. So who knows? I might come back at some point soon and tell you a little bit more about a new robot, a new droid that I might manage to make. Who knows? R2-D2 might live one day if I can build him in ROS 2. We'll see. So if you want to keep an eye on how my robot development and world is going, then you can see more of that across most social media platforms, and particularly YouTube. I'm Dr. Jon EA across all of those. Please follow and give me your thoughts, encouragement, and recommendations. Are always greatly appreciated. So there we go. Are there any questions about my fun journey?
Any questions?
Jon, how do you do your development on the, say, on the laptop side? Are you using a particular IDE, or kind of how are you going through that process?
So I do use a particular IDE, but I will say that I actually don't use it very much as an IDE. I use it as a text editor. So I'm old school. I use Eclipse, but for a build purposes, I'm building in CMake and Make, and that's all running in shell scripts and shells on my desktop.
Okay, thanks.
So, no more questions? I think that you have explained quite good. Okay, so Jon, thank you very much for attending and for explaining on this embedded working group. And that's all. See you to all of you next month here. So
Thank you very much.
Thank you and bye.